It is going to be another fatty, lots of information about drones and photogrammetry. So just to remind you of what we cover in the last, lecture, not everything, but just last lecture, it is going to be handy. I found this all the time, and the students, they appreciate that before I start every lecture, I show you what we cover, so you kind of get connected to what we will cover today. So in the last lecture, what we did is we did a quick demo on software, which is called Zephyr, and to use it to build our 3D full textured model. And then what we did later, our next is we simply look at the definition of drones and what are the different design of drones, starting from quadcopter, then fixed wing drone, and then finally VTOL. Every one of these drone, they vary in terms of price and in terms of application. So this is basically what we cover in the last class. In today's class, which I'm telling you, this is very important class. Whether your capstone project is going to be or related to the drones, or you are planning to pursue a career in drones, this class here is super important. You will see as we go, we will touch on so many topics connected to drone operations. So really what how I designed this is I designed this on a series of videos. Videos sometimes are very entertaining. They do way better than what I can explain. So I'm gonna show you some videos, and more importantly that I will comment on the videos after we finish, okay? The videos are, you can see on my screen. I'm running my video out of my PowerPoint presentation, and what you have on the D2L is a PDF. So that's why what I did is I included here a link, and this link will take you to the website on the YouTube, the specific video. So let's go ahead and watch our first video.
For just $67, you can make as many videos as you want, and you never need to pick up a camera or...
To get started, download the Pix4D app on your mobile device. Select Grid Mission since it is the easiest to use and in my experience produces the best results. As you can see, you can adjust all the parameters of the area that you are going to be mapping. The application will warn you if the area is too large to be flown. If you click on the battery symbol on the right hand side, a lot of vital information will be displayed. You can also adjust the altitude in meters. The higher, the less time it will take, but also the lower the resolution will be. I use 50 meters as that gives a good balance. There is also a camera mode, but I do not use it since it does not help me. Here are some settings that can be left alone. You can also reset the area to its default size. The predicted time to complete the flight is displayed in the lower left-hand corner. Once familiarized with the application, connect your device to the controller and fully charge the battery. It is also recommended that you update the software on the Phantom and on the remote controller. Place the Phantom in an open area that is clear of trees and other obstacles. The application will only work when the flight mode switch is in the F position, the leftmost one. If at any point you need to regain manual control, move the switch to the A position. Once you are happy with the shape and size of the area you are mapping, press start, read the instructions and press takeoff. The Phantom will now automatically take off and ascend to the indicated altitude. It will then fly towards the start point. Once there, it will fly to the next waypoint, stop, take a picture and repeat the process. Of course, be ready to set the switch to the A position if a problem arises. The Phantom will stay on course even if there's relatively strong wind. Once the mission is finished, the Phantom will return to the home point. I would advise landing the Phantom manually so you can land it in the correct place. Once landed, import all the images taken and download the trial version or buy Pix4D. Open Pix4D and select New Project. Name it and select where you want it to be stored. Now, import your images. As you can see, the images have been geolocated correctly. On the bottom are processing options. If the second step in processing does not work, try changing the quality or the output options. Click Start and the processing will begin. This process might take a very long time. It is recommended to have a powerful computer with a lot of RAM as it will dictate how many images you can process. I have 8 GB and my limit is roughly 100 images. Once the processing is finished, it will look something like this. To see the final result, turn off cameras and enable the mesh option. It will now load the mesh. The quality of the mesh may depend on the time of day, the altitude, and your quality settings.
So here is our first video, and I would like to have some comments and some chat with you guys about this video. So one thing I want you to take from this video is that uh, the using a drone simply you have to go through three different separate steps. Three, one, two, three, three. Those three steps are: number one is you need to plan for the mission. And this process can be completely done in the office. I would say better in the office to do. So you sit in the office, you run one of the apps, and I will talk about the apps later on. So those are available apps for photogrammetry. You can install them on your cell phone or tablet. So on the app, you will need to design your mission and set some parameters, including, for example, what is my area that I need to scan. So on a very neat background, which is the satellite image or Google Earth, you can simply set the boundary of your area in addition to setting some other parameters, like, for example, flying height and overlap and so on and so forth. So this stage is called planning stage. The next step is you take your drone, go to the site, and you place your drone, as mentioned in the video, in an area where there is no trees or maybe power lines close by. I'll let you know later on. Then once you pick this point, you start your mission. The app will completely control your drone. It's autonomous, so it means the app will send your drone to the right elevation. It will send your drone to the right design flight lines. And whenever there is a location where the camera it's supposed to take an image, then the GPS will trigger the camera and you get an image. Then what happen is the drone will be sent to the next point, to the next point, and so on. Go on a design flight line until the mission is finished and the drone would come back to where it flew from. This step here called data acquisition. So we're trying to acquire the data, which is nothing more than a georeferenced images, an image that was taken at a specific location on our area. You take your images, download them, and then start the stage number 3, which is data processing. And in data processing, we use a software. Now, one thing I want to remind you, like you guys have seen in my class, using Zephyr to process the data, okay? And in this video, you've seen another piece of software that is also used to create our 3D model. Although the two software, they seem very different, like name, like Bix4D, and the other one is Zephyr. I'm asking you, what kind of feeling you get in terms of processing steps? Are they the same or different?
Just looking at the software, it looks like it's similar, but it's also different. I'm not 100% sure.
So, I mean, you're kind of right. Like, you know, the software itself is a different software, so it has a different interface. But I know that the video was very fast and that's not in details, but here is my take on this one. Although you have so many software, however, the workflow, it looks exactly the same. While you just tell the software, here are the images, and you set some parameters, and then the software will go ahead and do the magic and build for you the 3D model. That is really my point. You know what? I'll give you more details later on, but for now, let's move on to our next video. So our next video is simply about another kind of drone, which we already discussed. We call this drone a fixed wings. It's just like any aircraft, any aeroplane, and it has a fixed wing. And let's watch the video and also try to see what are the different stage that if we decide to use this drone here, what it takes us to create a 3D model. Please watch this.
Imagine being able to achieve highly accurate mapping whenever and wherever needed, even in less than favorable weather conditions, such as wind, light rain, and cloud cover, where conventional photogrammetry simply won't suffice, while staying with both feet firmly on the ground. Introducing the Gatewing X100, revolutionary aerial mapping and surveying system. The Gatewing X100 is a game changer because this system is revolutionizing the surveying and mapping industry like never before. The gap between traditional terrestrial surveying and conventional photogrammetry has finally been filled. Now, surveyors can remotely and safely measure large, difficult to reach or dangerous areas. For photogrammetrists, smaller projects suddenly become highly cost-effective. The Gatewing concept consists of two main elements: image acquisition and image processing. Image acquisition is conducted using the X100, a light, unmanned aircraft with an onboard, high-quality calibrated camera which captures images with a resolution of 5 centimeters when flying at a default altitude of 150 meters. The image resolution can be altered by modifying the flying altitude. The strength of the system lies in the fact that flights are conducted in a fully automated manner, from launch to landing. No piloting skills are required to fly the X100. Instead, you merely facilitate the aircraft's operation, which includes indicating the area to be covered and selecting a takeoff and landing spot. Simply plan the area that needs to be scanned based on the easy-to-use software wizard. Launch the device and let the X100 cover the predefined area. Through parallel sweeps following a regular shape, the aircraft will then take high-quality pictures with a high overlap. The ground control station is only used to monitor the flight and to allow an on-site image quality check. The patent-pending sturdy body, made from expanded polypropylene and reinforced with a carbon frame, was custom designed by Gatewing engineers for its durability, power efficiency, and outstanding weatherproof properties. Because of the lightweight material and built-in fail-safe procedures, the X100 is the safest unmanned aircraft ever made. The X100 was designed for maximum coverage. With one single battery charge, the aircraft can scan several square kilometers. Another key factor in the design of the X100 was its employability in different weather conditions. The device operates perfectly in hot, cold, drizzly, and windy conditions, with wind speeds of up to 60 kilometers an hour. The X100 packs some amazing technology into a 2-kilogram platform with a wingspan of only 100 centimeters. This makes it easy to carry and use anywhere. All these features make the Gatewing X100 the world's fastest and easiest to use professional surveying and mapping tool. For the creation of orthophotos or digital surface models, Gatewing offers StretchOut, a highly automated software package that converts your raw X100 image dataset in no time with just a couple of clicks. If you do not wish to invest in standalone software, you can simply upload your images to the Gatewing cloud, and just a few hours later, you'll receive your orthophoto or DSM. With both software solutions, the quality of the results is outstanding, razor sharp, no artifacts, intense colors, and above all, the spatial accuracy, which makes it a true surveying tool.
Okay, so here is another video, very interesting video about another, design of the drone called fixed wings. Let me ask you a question now, please. Now you've seen that's a completely different, design for drone. We went from quadcopter to fixed wings. Do you see any difference in terms of the steps or the stages that you have to go through to produce your 3D model?
It's essentially the same process.
Exactly, it's the same process. So no matter what is the design of the drone that you're using, whether VTOL or quadcopter or or fixed wings, the process the same. I know that in this video they say 2 stages, but in fact it looks like they are 3 because they are still the same thing. You have to pick the area that you want to scan, set some parameters, and let the drone fly. And we call this as a planning stage, So that's one thing I want to everybody to understand, that the stages or the steps that you have to go through to produce a 3D model, essentially they are the same, including data, like, first of all, you have to do planning, then data acquisition, and then finally data processing. So that's one thing. The other thing is also I want to, reference something in this video, which is the processing. So the processing, probably I can go a little bit back in the video. So the processing here is, say, mentioning something called stretch out. Again, don't bother so much with the name, because those one of the so many available software to create a 3D model. We already, in my class, you've seen so far, you've heard the 2 names at least, Zephyr, you've heard Mushroom, you've heard Pix4D. How many? There are so many. So stretch out is this company solution to create a 3D model or digital surface model or orthophoto. However, you can access this service through different options. One, you can buy a license, you can buy the software itself, or the other option is you can upload your images to the cloud, and in the cloud, there is the software will process the data and send you back the downloaded, the results. And by the way, so you know, this kind of a trend, almost every company right now, they go with this business model. So it's a model where, well, if you use the software every day, probably you need to buy the software. But what if a company that maybe performs drone survey every 6 months? Do they really need to pay for the license or just to upload the images and get the 3D model? I think it's even cost effective to just pay as you go. So you pay per project, and that's kind of a model that every single company today they apply. Bix4D, they have the same option. Every company right now they offer you to buy the license, or the other option is they can do your processing and send you only the final results. So this is something I want to mention for everyone, just in case if you work for a company and you need to be aware of those services. The next part is I'm going to switch to the last, the last and so did you guys have you seen how this drone fly? If you remember this fixed wing, so it came with kind of a platform, and this platform will give an initial speed and send this drone to the right elevation. So I'm asking you, can we use this operation in built-up area where you have lots of building? Can we do that?
It'd definitely be a lot more challenging than using a quadcopter that could just go up and down, straight up and down, versus having to have some sort of horizontal flight path first to get to altitude.
Exactly, that's my point. And if you remember, there's an amazing design which is called VTOL, and the VTOL simply it does both of them. And remember, this is like being not able to or not easy to fly this drone in built-up area. But I'll tell you, this drone, because the way it flies, it can cover several kilometers with only one battery charge. One battery charge. And also there are some other, secrets I would like to share with you. Those drones, uh, I said because of the aerodynamics around the wings, so they can fly for long distance with consuming a single battery. In this video, they said they can cover a few square kilometers with a single battery charge. That is true, but let me point out something very important. I'm not sure it's going to be obvious for you. For a quadcopter, it can do a 90 degrees turn. For a quadcopter, it can do a 90 degrees turn. It means it can stop, turn right, or turn left. And this will save time in maneuvering. In fixed wings, if you watch the video, I guess I can go back to where it shows how it turns. Uh, let's see. Yep, I think somewhere here. Do you see at the end of every flight line, do you see how it turns? It has to go on a radius to go back to the next flight line. And this will also consume some of the energy. So I would like to tell you that the fixed wing drone are very, very compatible with the linear project. So if you have a project, for example, like road design or maybe power line survey, the best drone is fixed wing because simply it has to go almost in a straight line without wasting energy to turn on those radius. Okay, now let's move on to the last part, which is the product. So in this picture here, you see the product, and this is an orthophoto. And I think in my class, you learned about orthophoto. It's a photo that we have removed all the relief displacement, and it simply contains the advantage of map because it has only one scale, and also has the advantage of photo because you can see it's rich of color information, where you can see where is the mine, where are the trees, and because color information are amazing, they are nice to have color information, not just like a map that has some names. Now, so you can see here we have a very nice product. The point density is super high. We have like density, maybe a few centimeter between the points. So this is really an amazing product. One thing I want to mention is that in this application here, so it looks like this is kind of an open bit, like kind of mining application. So what is the competitor technique for photogrammetry? like how people they used to estimate the cut and fill in mines before they have drones. And remember, when you have a mine, you're not supposed to fly an aircraft because this will not be cost effective, because it will be very expensive. If you want to find cut and fill, you fly an aircraft. However, with the drone, now we can simply fly our drone to do the mapping for this mine. My question for you is, before drones, how did we use to find the XYZ on a mine? The answer obviously would be either total station or GPS. Now, with GPS, especially for this application, is it easy or difficult? What is the danger? What is the problem here with this application?
You'll have to physically go to every individual part of the mine, and some parts of the mine maybe not the most accessible on foot.
Exactly. Look at those. Look at exactly the picture I'm showing right now. This is like this is the mine. So there are kind of a stepped slope. So we call them berms, and those are, I think, in my opinion, those are very dangerous to walk on. So they kind of contain a hazard. In addition to that, down in the mine there will be lots of moving equipment like dozers, and this is completely unsafe. And sometimes you hear injuries and hear fatalities because of of this operation. Now with drone, you are completely remote away from your from the the surface, and you can still create this fantastic product here. And also it has to do with the speed. Look at the speed. Look how long does it take to simply survey this mine. For sure, if you think about the speed, photogrammetry can do it very fast in terms of data acquisition. So you can repeat the process maybe on a weekly basis or maybe on bi-weekly basis, while before you can do it maybe on a monthly because it takes more time and more effort. So anyway, I kind of took you through the process, and in general, the process is the same regardless the design that you choose for your survey, the design of the drones. Okay, let's move on to the next slide. The next slide, it kind of puts everything in a perspective, which is the the photogrammetry using drone. It includes 3 steps, and I will talk in more details. I know that you've heard this before today, like that every drone operation, you need to go through 3 individual steps, which is flight planning, then data capture or data acquisition, and then finally data processing. But I would like to add more details on every stage. So for example, for flight planning, here are the steps included in the flight planning. Number one, you must pick the right drone. I think we already touched on this one. For example, if I have a linear project, like for example, road survey that goes for maybe few kilometers, what is the best kind of drone? Simply, it's fixed wings, because simply it can fly on or maybe 1 time or 2 times and it cover your entire road. While if you try to do that using quadcopter, because of the battery life, it will take way more long time. So that's picking the right drone. Number two is pick the right application. And I know some of you will wonder, why do I need to be careful when I pick the application? And remember, I'm not talking about processing. I'm not talking about creating a 3D model. When I say application, I'm referring to the data collection. So there is one app on your tablet, on your cell phone. It controls the drone to go along design path and give you the required photographs or images. Now, in the market, there is, I would say, plethora of applications. One of them, which I will give you a demo straight after this slide, called Bix 4D Capture. And you need to know that Bix 4D Capture is not Bix 4D. So in my class today, you hear the two names, Bix 4D Capture and Bix 4D, and those are different. Bix 4D simply takes your photos, create a 3D model, and this is a software, and you need to pay for the license. While Bix 4D Capture, look at the name Capture, it is designed only to capture the photo, to control the drone and capture the images. Now, this is a free app. You can download completely free of charge. and you use it to not only to create a 3D model, rather than controlling the drone to take for you the images. In the market, there is, I would say, hundreds of those apps. I can mention maybe a couple of names, maybe Bix 4D Capture and Drone Deploy. Some of them, they are free, like Bix 4D Capture. And on the other side, we have Drone Deploy, which is you have to pay, I think, $30 or $35 for it. Now, why we have so many applications, they do the same thing, is because even we have an like application in mind, we need a specific app, because not all the apps, they can do the same flight pattern. I'll give you an example. For example, I'll give you an example. Let's say you're trying to map a high-rise building. High-rise building. You wanna, map, create a 3D model for a high-rise building that, let's say, 30 or 40 floors. Now, you cannot use Bix 4D capture to do that, because you cannot find any flight pattern that can cover the sides of your 40-floor high-rise building. Other software, they provide a spiral pattern, spiral. So you go on maybe on the second floor and you turn around the high-rise building, and as you go, you increase the height. So that's called spiral. And this is what you need to build a 3D model for your high-rise building. This pattern is not available at all in Bix 4D. You get the idea, huh? So it depends on what you're trying to do. You would pick the right application. Number three is understanding the site and the application. Now, what do you mean understanding the site and the application? I'll give an example. So you need to understand the site. You need to visit the site without any drone. Just go there and walk around the site. Ultimately, you get yourself familiar with, do we have building? Yes or no. Do we have trees? Yes or no. Do we have power lines? Yes or no. How high are the trees? How high are the trees? Where can I fly my drone? Where my drone will land? All these questions, it has to be answered prior to the actual flight. Okay? And I'm gonna, for example, show you, for example, the importance of understanding what is the height of the building in your project area. For example, let's say I want to make a map for SAIT. If you guys still remember SAIT, huh? SAIT, most all the buildings are kind of equal in height, probably 3 or 4 stories, while there is only one building stands up for 12 stories. Okay. Now I'm asking you, when I fly my drone, should I fly at elevation, for example, 20 or 20 meter? Think, please. Like, let's say, like Aldrich Center, let's say it's a 20-meter above the ground. Can I fly on 20-meter above the ground? Can I fly on 15? So otherwise, you have to understand that you need to look at your site and try to get some information before you do the actual flight. Because otherwise, if you're not really paying attention, you could end up with a disaster. You could destroy your drone, or maybe hit a window. So you get yourself familiar with the site. Also, power lines are very important, because simply power lines, they disturb the GPS signal. So we need to understand that we have to be away from them. Picking where should I fly from, like the takeoff point and the landing point, is also important. I need to pick one area that is kind of flat. You don't have to, or you don't want to land your drone on a slope. Otherwise, probably will destroy your drone. So you need flat area, clean, away from trees and power lines. So all these discussion has to happen before you start your actual flight. Next is, now I know that I already came up with some parameters. How high should I fly? All those questions. Next is, I need to choose the day and the time. The day and the time. Let me give you some example. What if I have a day that it's minus 40? Can I fly my drone in minus 40?
You'll probably run into issues with the battery when it gets that cold.
Exactly, sir. That's exactly it. So the manufacturer will tell you the safe operational range. For example, it will tell you between 0 to, for example, plus 35. Within this range, you should fly your drone. Otherwise, there could be a problem with the battery. And if there is problem arises with the battery, you know what happens, huh? Your drone will fail. If you have a battery failure, then your drone will fail to the ground. So that's one example. The other example is, for example, if it's rainy, if it's foggy, can we fly our drone in a foggy day, like a day that you cannot even see maybe a few meters away? That's not really okay. And you will see when I talk about the regulations, this is forbidden that you fly your drone in a foggy day, and you will know why later on. But anyway, next is, let's say I pick one day. So in that day, I have a day from 8 o'clock in the morning until, let's say, 5 in the afternoon. Should I fly my drone very early in the morning or very late in the afternoon? I know this answer is not easy, okay? Really, you should fly early afternoon. You need a minimum shadow because photogrammetry is not a friend of shadow. We need simply good lights, and also minimum shadow. Next is, after you do all of that, make sure that you have all the authorities' approval. We will talk about this step in more details at the end of our class today. Now, finally, this is very important because some people, they forget about this. You need to obtain the owner's approval before you fly. So, for example, let's say I am a set employee. I got all the license and I have done everything you can imagine, but I forgot little thing that I need to communicate with SATE and tell them that I'm performing my test on that day. Is that okay? It is completely not okay. You must get the property owner approval if it's a private property. Okay. So this is simply all those are included under flight planning. Next is when everything on the left side here happens, then now we can go to the site, and you've seen it in the video. Very simple. You start the application, and the application will take control of your drone and will send your drone to the right elevation. Will send your drone to the right location and simply trigger the camera to take image at specific location. I need to remind everyone that in photogrammetry, it's not really random images. We're not taking random images and we're creating 3D model. The images must meet specific geometry in terms of overlap. If the images, they have no overlap, then I'm screwed. I'm just going to throw them in the garbage. The images. If my images, they have a specific overlap, then I can use them to build a 3D model. In addition to the geolocated images, I also need to collect some ground control points. So we need to mark on the ground some points and then find the XYZ, not many, probably three, for example, 3 or 4. There are some rule of thumb on how many ground control point and the distribution on the ground. But if you want to get the best 3D model, then you need ground control point. Recently, they developed an RTK drone, a drone that contains real-time kinematic GPS. And in this case, people, they claim, no, I don't need ground control, like no control point on the ground, and I can completely build my 3D model without any ground control point. Now, once all this is happening, you move to the last step where it's data processing, and I'm not going to spend any time because I already gave you enough information on data processing. Okay. Now, what I will do between now and the end of, not the end, until the break, I will simply take you through the BIX 4D capture. So BIX 4D capture, as I said, it's an app that you need to install on your cell phone or your tablet. And remember, on your cell phone or tablet, what is the operating system? Any help? What is the operating system if you're using a drone or tablet?
It'd have to be Android, right?
No, by the way, so those companies are smart. They make two developments, so they develop their app for Android and also for OS, so it's available also for iPhones. But my point is, this is not really a Windows-based system, huh? So what happens here? I wanted to show you guys the app. So I found out that you can run any Android app on your tablet, on your laptop. You can do that. So you can run an Android app on a Windows-based system with the help of something called the emulator. So the emulator here, I found one called the BlueStacks. You can see I'm running this one. Looks like people used to use it to play games, which I'm not. I'm not a gamer, but you can see here the screen. So really what I did is I downloaded Pix4D because you can see here on BlueStacks, you get Google Play. So you can get Google Play on, if you double click on Google Play, you can search for the app and can download it. Anyway, so if you're interested, you don't have to do that, by the way, because simply I'm doing this only to show you on my screen on my laptop. But for you, don't have to do that. You just can, if you're interested and you want to play with it, you can download on your tablet or your cell phone. So here is Pix4D Capture. I'm running it. And the first thing you will get as soon as you start your Pix4D Capture, it gives you this window here, and this window, it has a discussion that we mentioned before. The first window, it gives you the different flight pattern that you can use for your project. So starting from the right, you can fly free mission, so you can completely control your drone on the right side, called flight mission. The next one is called circular mission, which means you have one object in the middle, let's say a building. You can click on it, and then it will, the drone will circle around your building. Okay. We have other mission design. We have a double grid, we have grid mission, and then finally on the left we have polygon mission. To be honest, the most left and the grid mission, those are very similar. The difference is grid mission allows you to choose a square or rectangular area of interest, while the most left, it allows you to create any polygon and to scan. The one in the middle, which is double grid, this is the most favorable one, because simply the way it goes is that the drone will start somewhere, will go into zigzag in one direction. Once you cover the area, you simply go perpendicular in a zigzag line. And this gives you the advantage to cover the building from all sides. Okay. So this is really good for creating a beautiful 3D model for example, for a subdivision. If you are interested only in two-dimensional, like not really the size of the building, however, only the top of the building and the roads and stuff like that, probably the grid mission or maybe the polygon mission will be okay for you. You know what? I'm not going to spend more time on this window here. I will right away click on one of these missions. So click on polygon, and as soon as you click on polygon, what it does, it simply gives you a kind of interface where you have a map on the background. And let's watch this. So I can simply turn my map into satellite image. And you guys know, this is not new. This is probably available on your cell phone if you're running any mapping application right now. Google gives an access for all those apps. Now, what you can do also is you can turn your location on. So I'm turning my location on, and you guys know where I'm right now. Okay, so you can see here the software will simply pick for you your location and simply display for you the on the background your satellite image, on which you can simply create a polygon. Okay, it's not really nice. To be honest, I I struggle with using the app here on my tablet, but I'll show you the idea. So the idea here is that you get a polygon, and you can simply move your the boundary. You say, okay, here is my boundary. You know what? I'm going to stretch my area. So here is my area of interest, and please understand what are those white lines. So those white lines are simply the flight line. So the drone will have to go and fly along these flight lines. And you can see it looks like a zigzag line. And so on these flight lines, the drone will simply capture the required photos. Now, there are few controls here. So let's say I'm happy with this area. Let's say it covers my area of interest. Now, there are some controls, which is how high you fly. Right now, the flying height is 63 meter. You can see this on the far left side, 63 meter. And of course, you can increase or decrease your flying height. Now, I'm asking you, I need some of you guys to help me, please. Should we fly very high or very low?
I mean, it depends on what you need to do, but the higher you go, you could be entering into reserved airspace, so you could get in trouble. So I guess you'd need to figure out what your requirements are.
Okay, thank you so much. You're kind of stepping ahead, but that's great. That's great that you're thinking about those kind of regulations. But let's say I'm okay to fly under 200, under 122 meter, and that's the rules. Maximum 400 feet above ground. So that's my maximum height. No problem to fly below that. And then I have no building, so I have no building, so it's kind of no building. Let's say I can fly starting from 10 meter. Should I go with 10 meter or 122? So I'm kind of excluding those regulations. So you know, huh? I'm just putting regulation side on the side. I'm asking you, should we fly very high, like 122 meter maximum, or 10 meter above ground?
The closer to ground you travel, the more depth your model will have. Whereas if you're flying higher, it's going to be flatter because it's more difficult for the program to be able to perceive the different heights of objects, but it'll be a lot faster to do.
So you kind of touch on it. So here we go. I'm going to tell you the secret. We shouldn't fly very high. You shouldn't fly very low. You have to be a trade-off because every one of those, it will have an advantage and disadvantage. Watch this, please. So I'm going to show you here two numbers. So I want everyone to look at this GSD. GSD. So GSD stands for ground sampling distance. And what does it mean? It means every pixel on my image, how much does it cover on the ground? Every pixel on my image, how much does it cover on the ground? That's called GSD. Right now, the number is 3.9 centimeter per pixel. Also, on the other hand, look at the bottom. So on the bottom here, the 4 minutes 30 seconds, this is simply your flying time. Your flying time. Now watch me as I increase the height. So I'm going to increase my height. I'll go to 100, let's say 100. I know that there is a problem here with the area, so I will try to stretch. Not very nice, to be honest. If I'm using my cell phone, probably will enjoy more than what I'm doing right now. Okay. So right now, the area that I want to cover is 234 meter by 113. You can see the size of the area is here. And I need 5 minutes, huh? 5 minutes to cover it. And the ground resolution is 5 centimeter. If I go up, so increasing the height from 81 to 90, so what happens here is, looks like I'm losing resolution. So I'm getting a cursor, like I go to 5.26 right now, and somewhere the time will drop to 4.3, 4.5 minutes. Okay, so if I go down, what happens is when I go down, for sure my image is very close to the ground. It means I see more details. It means my GSD gets smaller. I have more details. On the other side, what happens to the time? For sure, at one point, the time will be, for example, 6 minutes or 7 minutes. So you can see here, I go higher, I see less, but I need more, I need less image, I need less flight time. Are you guys following? If I go up, I see less details, but I have my every image will cover more area on the ground, and I need less images, and I need less time. And remember, the time is important because it's connected to the battery life. Now, once you're happy with all those settings, okay, there are more settings here. So if you go on the top right, if you drop the menu here, we have some settings. I'll go one by one. So you can control here the speed of your drone. You can go from very fast to very slow. Let me ask you, which one you think will give you a sharp image? When your drone is moving slow or your drone is moving fast?
When it's going slower, it's a better resolution.
The resolution will be the same. It's about the quality. So the resolution is function of the focal length and the focal length and the flying height, and also the size of your of the sensor on your camera. However, the resolution is the same, but the quality of the image will be different. If you fly very fast, simply your image could be blurred, like like a hazy. If you fly slow, then you get sharper image. Do you agree? This needs some photography skills. Like if you're taking an image while something is moving very fast, what happens?
Little blur.
You get a blurry, hazy image. That's why there are some sport camera, and sport cameras, they are designed in a way that they can capture things that's moving fast. The way you do it is they make shutter speed very, very high. Okay, that's called the sport camera. Anyway, so you can see here, I can simply control the speed of my drone from slow to fast. But remember, when I go slow, I need more time. When I go fast, I need less time. You can see the time is changing. Watch this. If I go slow, I need 5 minutes, 30 seconds. If I go fast, I need 4 minutes only. So I'm saving 1.5 minutes. And again, look at this. This is a very small area. If I increase the area, you will see this will make a big difference. Next is, you can control the camera orientation. Right now, the camera orientation is 45 degrees. It's kind of an oblique image, while I can make it completely vertical, or I can make it completely horizontal. Now, which one you want to do? This is a difficult question, by the way. You want to orient your camera completely vertical, or you want to make it a little bit oblique?
A little bit oblique because it'll help you determine, I guess, 3D objects better than just a straight up and down shot.
Thank you. So that's perfect answer for sure. If you make an oblique image, in this case, you get better elevation accuracy. In addition to something you're not paying attention to, if you're making a vertical photo, probably you will only capture the top of the building. But if you make an oblique photo, you will also capture the sides of the building. Okay? Anyway, next is overlap. So the overlap is simply the overlap. We will talk about overlap in lots of details in the next class. But right now, with the overlap percentage is 70%. So I'm taking an image, and the next one, it has an overlap of 70%. And if I go high, it goes even to 90%. Remember, if I have no overlap, can I create a 3D model?
Nope.
No, you cannot. This is, this is ABC photogrammetry. No overlap, no 3D. You can see here, even the software doesn't allow you to have like a small overlap. You can see the software start from 70% and you can increase to 90%. Remember, when you increase your overlap, I want you to see the pattern of my flight line. Watch this, okay? So if I decrease my overlap, the flight lines will get spaced. When I increase my overlap percentage, I get more flight lines, which means I get more flight time. Look at this. Look at the 16 minute right now at highest overlap. When I go to the lowest overlap, I go to 5 minutes 30 seconds. Okay, so you can see overlap is also one of the player in the game. Okay, you know what? Let's say I'm happy with all those. Watch this. So if I'm in the office right now, what can I do? I'm in the office. I'm not really on site. I'm not ready. My drone is not charged. Nothing is ready. What should I do? I can simply go to save. On the bottom right here, I can save my project, because simply once I save my project, I don't have to repeat this business on site. When I go to the site, I just upload my project. Okay. However, if you're doing this process on site, let's say I'm ready, my drone is charged, everything is ready, I can right away press on start. When I press on start, I'm not going to do that right now because I don't have a drone. Simply, the app will look at the drone, check the sensors, make sure the camera is working, the GPS was working, upload the mission into the drone brain, and simply give some instruction to the drones to fly. And remember, the drone will fly somewhere here, let's say somewhere here, will go to the right elevation to 60 meter up, and then turn straight line into the first flight line, will go and proceed along the first flight line and take one image here. After one distance, we'll take another image, another image, another image, another image, until here. Then it turns on this angle, and it goes back in a zigzag pattern until it covers the entire area. Once finished, it goes back to where it flew from. Okay, so with this right now, I'm done, and we'll give you 10 minutes break. Before the break, do you guys have any question for me? Do you have any question for me?
Not so far.
Okay, so we'll see you guys in 10 minutes. I'll see you back here. 9:08, 9:08, please. Thank you.